All right, here we go with our notes on solving one-step equations. Before we jump into actually solving equations, I want to start with just a definition of what an equation is. An equation is very different from an expression in that it has an equal sign, and it is essentially two expressions that are set equal to one another. It's a mathematical statement that says that two expressions are equal to one another. All right, so that's going to be our definition here. An equation is a mathematical statement indicating the expressions on both sides of the equal sign have the same value. Or in other words, that they are equivalent. Okay, so the definition for an equation is a mathematical statement indicating the expressions on both sides of the equal sign have the same value. So an example of this would be the equation 5 plus 4 is equal to 3 times 3. So notice that we have two expressions, 5 plus 4 and 3 times 3, and we're setting them equal to one another. We're saying that these have the same value. They are equivalent. And indeed, 5 plus 4 is 9, and 3 times 3 is also 9. We know that 9 is equal to 9, so this statement is true. This equality is true. Okay, so that is an example of an equation, two expressions that are set equal to one another. Just like how we can simplify expressions, we can extend that further into equations. And so now we call them solving equations. So in order to solve equations, we do the following. Notice that we simplify expressions and we solve equations. All right, so in order to solve equations, the solution to an equation is the value of the variable that makes the equation true. So the solution to an equation is the value of the variable that makes the equation true. And if you look ahead, we can see our four examples here. Each of these examples are equations, and each of them have unknown variables, right? We don't know the value of these variables. These variables, once we find the value, right, when we find, like for this first one, x equals, but we find out what it's equal to, that's going to be the solution to our equation. It's whatever the value is that makes this equation true. All right. In order to solve, we need a goal. So the goal, in order to solve, is to isolate the variable. So we'll say isolate the variable or get the variable by itself. We're going to do that using inverse operations. So we isolate the variable using inverse operations. So some examples of inverse operations. So let's go ahead and write that, inverse operations. Some examples are addition and subtraction. So addition and subtraction are inverse operations of one another. The inverse operation to addition is subtraction, and the inverse operation to subtraction is addition. Likewise, inverse operators of one another are multiplication and division. So the inverse operation to multiplication is division, and the inverse operation to division is multiplication. So in order to isolate the variable, we use these inverse operations. Let's take a look at a few examples. This first one, we have x plus 4 equals 11. In order to solve this, we're going to take a look at what operations are occurring in this equation. Well, right now I see we have x plus 4. I see addition. So we're going to use addition's inverse operation in order to solve this. So the inverse to addition is subtraction. So we are going to subtract 4 in order to zero out this plus 4. Now, if we subtract 4 from one side of the equation, you also have to do that to the other side. All right? If you do one thing to one side of the equation, you have to do it to the other side, the exact same thing to the other side as well. Okay? So this plus 4 and minus 4 zero out. So all that's left on the left-hand side of the equation is x. We'll bring down our equal sign, and we have 11 minus 4 on the right-hand side. Well, 11 minus 4 is 7. So we have x equals 7. So our solution here is x equals 7. And we can always double check that this is indeed a solution by plugging it back into our original equation. So we can take 7 and plug it back in for x. So we have 7 plus 4 equals 11. And then let's go ahead and simplify this left-hand side, this left-hand expression. 7 plus 4 is 11. So we have 11. Bring down the equals and bring down the 11. Well, is that true? Is 11 equal to 11? It sure is. So the equation is true, which means this is indeed the solution. Moving on to this one, we have 14 equals a minus 8. I see that we have subtraction occurring here. So we have to use the inverse operation, addition. So instead of subtracting 8, we're going to add 8. And if we add 8 to one side of the equation, we must add 8 to the other side of the equation. The minus 8 and plus 8 zero out. So all we have on the right-hand side is a. Bring down the equals. 14 plus 8 is 22. So we get this solution here. A equals 22. And equations, you can switch them around. You can say 22 equals A. You can say A equals 22. Either way is fine. All right. And I'll leave it to you to check your answer by plugging it back in. Let's try example 3. Here I have negative 7y equals 21. A lot of students will see this and see, oh, minus 7. I have to add 7. But be careful. Consider what's going on between the 7 and the y. There's multiplication happening in between here. So you can think of this as negative 7 times y. So in order to undo multiplication, we perform the inverse operation, division. So we're going to divide both sides by negative 7. And don't forget that negative. Well, negative 7 over negative 7, well, that's just 1. So those cancel out. So we have, you could say 1y, or you could just say y equals, and then we have 21 divided by negative 7. Well, 21 divided by 7 is 3, and we have a positive divided by a negative, so the answer is negative. So we have y equals negative 3. Last but not least, we have 6 equals q over 2, or q divided by 2. So the operation happening here is division. So in order to undo division, we have to do its inverse operation, multiplication. So we're going to multiply both sides by 2. To get rid of that divided by 2, we multiply by 2. And then we have 2 over 2. Well, again, those cancel out. So all that's left on the right-hand side is q. Bring down the equal sign, and we have on the left-hand side 2 times 6. Well, we know 2 times 6, that's 12. And again, you can leave your answer as 12 equals q, or you can write q equals 12. Either way is fine. All right, so this is a quick notes on solving one-step equations.